should have learned this in Algebra 1. Absolute value inequalities. We haven't hit Algebra 2 yet. In fact, I don't even know when we're going to hit it. I really don't. I think it's after Unit 1. Okay, so we did compound inequalities, right? Right. Yes, we did. Yes, we did. The and and ors. Don't fool me. Okay, with absolute values inequalities, we do follow the sign. Okay, the less than symbol are the and problems, and the greater than symbols are the or problems, right? Yes, ma'am. Yes. Wait, okay. This is actually a really good question because a lot of students get confused with this. Guys, when we, first of all, make sure you have the absolute term by itself. And yes, when you go to split this up, okay, we take what's inside, 2x plus 7 is less than 11. We leave everything the same. But then when we split it up the other way and make it to the negative 11, remember the left sign of the number 9? We're actually multiplying it by negative 1, so absolute value inequalities the sign has to flip. Now, I always put the negative number over here and the positive there because when we go to put it on the number line, it's your smallest number, greatest number. It's just me. Don't try not to get confused if I accidentally switch them because it's just habit for me. Okay? You could do it either way also. Does that answer your question? Okay. So when we go to solve this, you have to solve each inequality, just like the compound inequalities, right? We had 2 inequality statements. We're making 2 inequality statements out of 1 because of those absolute value symbols. Okay? We got to consider both places. Remember, to the left of 0 and then to the right of 0. All right, let's solve each one of these. See, I'm going to subtract 7 from both sides. And I get 2x is less than 4. Divide by 2. And I get x is less than 2. And solve the other one. Subtract 7, subtract 7. I get 2x is greater than negative 18. Divide by 2. Divide by 2. And I get x is greater than, I'm dividing by a positive number, so keep the sign the same, negative 9. See how I have to flip these now? By the way, as I pointed this out yesterday, this is the distance, right? 11 is the distance because we have absolute value symbols and we have the distance on the other side of the inequality. These are location points, right, on that number line. So these can be negative. This cannot, unless it's an or. This is the confusing part about absolute value inequalities. And I'll get into examples of why we can't have a negative number with the and problem. All right, so I need to put the smallest number on this side, the larger number over here, and the graphs. What kind of graphs? they're in between, right? Bracket, parenthesis, and they're in betweens. Ors are what? 90% of the time? Bracket, parenthesis, towards the negative infinities or positive infinities, right? Remember from compound? All right, so we're expecting these to be shaded in between, right? Do I have parentheses or brackets? Parentheses, no equal signs. So they're in between. And the interval for and problems are pretty easy. You just copy down what's there, right? And we're done. Or problems. I'm expecting 90% of the time for them to go opposite ways. So I'm going to add 2. I get 3x greater than or equal to 10, and then divide by 3. I get x is greater than or equal to 10 thirds, or add 2 to both sides. I get 3x less than or equal to negative 6. Divide by 3. And I get x is less than or equal to negative 2. Okay, the small number is negative 2. The larger number is 10 thirds. Brackets are parentheses. Brackets on both, right, because of the equal sign. And they're going to go out to follow the sign, out to negative infinity, and out to positive infinity. And the interval, well, this interval goes from negative infinity, negative into 2, and includes negative 2, right? Union, bracket 10 thirds, is the smaller one, and infinity is the large number. Always gets parentheses. Yes, sir. I don't care. It doesn't matter to me. All right. We do have negative 2. It's the arrow's pointing that way. Here's my negative 2, so shading that way. Yeah, that's why I like to put the negative sign. I like to switch them. I would have liked to put this one here and this one here, so that in the end I don't need to put them opposite. You know what I'm saying? The book does it kind of backwards. Wait a minute. Are you is what kind of problem? And or. That's right. It's an or. Greater than. Yep. Greater than are ors. Okay. Less than. After the absolute value symbols are by itself. Less than is and. Yeah. Okay, so this is an OR problem. I'm expecting them to go opposite ways. Now I'm going to put my negative 2 over here. Since this is all by itself, I'm going to put my negative 2 over here. So I got 4x plus 10 to the opposite of what's there, so negative 2, and I have to flip the sign. Or 4x plus 10 is greater than 2. See how I got my less number here and my bigger one there so I don't get confused. Just easily done. All right, solve for x. Subtract 10, subtract 10. I get 4x is less than negative 12. Divide by 4, divide by 4. And I get x is less than or equal to negative 3. I'm dividing by a positive, so I keep the sign. Or, solve the other one. Minus 10, 4x. Am I going too fast? How did I what? Sorry, my fault. Anything else? Okay, so I get 4x is greater than negative 8. Divide by 4, divide by 4. I get x greater than negative 2. See how my bigger number's on the right-hand side? Are you with me? Huh? Smaller number, bigger number. Want them going the opposite ways. Follow the arrows. I did it again, didn't I? Okay, x is less than negative 3, so it's a parenthesis less than, going out to negative infinity. Parenthesis, no equal sign, goes out to positive infinity. Write the interval. See, negative infinity, negative 3, parenthesis, union, negative 2, positive infinity. Questions, comments, concerns? Everybody with me? Did I go too fast? Anybody confused? Who's confused? Because it all stems from Venn diagrams. Back in elementary school, they used to teach that, they'd have the two circles, and when you have an or problem, it can work in this circle or that circle. And the word for or was union, a big U. We still use that today, but we don't teach Venn diagrams that much anymore. It's just terminology. It's used for or. It can work in this set or this set. That's what union means. Intersections are actually and problems. Okay? These are intersections because they work in both. They have to work in both. And that would be the overlapping circles in the Venn diagram. Intersection. Yeah. All right. I wish they still taught that. Really kind of, especially the whole different number systems. It really makes a lot of sense. Natural numbers, all that other fun stuff. Oh, this B? Yeah, something's going on with B because you see the asterisk, right? Yeah, but think about this. We have, that's good that you're looking at that, because there are situations where you have no solutions, okay? This will save you a lot of work. You're the first student ever that noticed this. The years I've been teaching Algebra 2, okay? The absolute value system, the absolute value term is by itself, right? So that means that whatever comes out of my absolute values is what? Well, be careful. This is an or problem, right? This is greater than or equal to. Will this, you have to ask yourself, will this be true? Is this possible? Well, yeah, it's possible because they're all positive numbers, right? 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 Anything coming out of absolute value is positive numbers. So what numbers are going to work here? Save yourself a bunch of work. What numbers is going to make this statement true? I was so proud of you just like 2 minutes ago. You're so close. That's okay. We'll do the work. We'll just do the work, see what happens. Okay, this is solve for. We're going to split it up. 2x plus 3. I'm going to leave the negative over here because when we take the opposite of a negative number, it's going to be positive. I want the bigger number over there. So I'm going to leave this greater than or equal to -4. It's an or problem. So I've got 2x plus 3. The opposite of -4 is what? +4, but I did multiply it by -1, so I have to flip the sign. With me, Ethan? Good. Solve each one. Subtract 3, subtract 3. I get 2x is greater than or equal to -7. Divide by 2, divide by 2. I get x is greater than or equal to -7/2. Or subtract 3, subtract 3. I get 2x is less than or equal to 1. Divide by 2, divide by 2. I get x is less than or equal to 1/2. Go ahead and plot these. -7/2 is a small number. Positive 1/2 is a bigger number. Okay. Let's see. I want all of those numbers greater than or equal to -7/2. In other words, I'm going to shade to the right. There you go. Okay, bracket, because it has an equal sign. And I'm going to shade, follow the arrow. Everything greater than goes out to positive infinity. Here's my 1/2. Follow the arrow. It's a bracket. And I shade everything to the left. Negative infinity. Which numbers work here? All real numbers. They overlap, going opposite ways, so they include all real numbers. Double bar R, yeah. Double bar R. All real number symbol. All reals, yeah, that's fine. You were so close, Warren. Any number coming out of absolute value is going to be what? Positive, right? Any positive number is always going to be greater than or equal to a negative number. In fact, greater than, right? So it's always going to make this statement true. We could have saved ourselves all of this work, realized that this statement's always true. It's going to equal all. You were so close. First student that recognized something was going on. C. Think? Okay, so think about it. All of these numbers coming out of this absolute value is going to be positive, right? Exactly. Okay, this is going to be no solution. If you're adding 8 to a positive number, can it ever be less than or equal to 5? No. But if you didn't know that, you would have to end up solving this. The first thing you have to do to get the absolute value by itself, subtract 8, okay? You get the absolute value of 4x minus 9 is less than or equal to -3. That makes it a little more obvious. Anything coming out of here can't be less than a negative number. Okay? And D, do we need to do D? You guys had enough of me? Oh, you shouldn't leave it unanswered. That means I'm going to do it. Add 4 to both sides. I get the absolute value of -x plus 5. It's going to be greater than 10. I don't see anything unusual about this. So this is an OR problem. It's a greater than. So I'm going to split it up. -x plus 5. I'm going to flip the sign, get my negative on the left-hand side. It's an OR. -x plus 5 is greater than 10. See how I got my negative and then positive? Subtract 5. I get -x is less than -15. Divide by -1 or multiply by -1, doesn't matter. And I get x. Flip it, because I'm dividing by -15. Or -5 minus 5, -x. -x is greater than +5, and then you flip it, right? X is less than -5. Let's graph those. Let's see, bigger numbers 15, smaller ones -5. Both parentheses. Just put it in. Thanks, Will. Let's see, both parentheses, right? It's an OR, so they're going opposite. Greater than. So nothing really special with this problem. The interval, -infinity to -5. Union, parenthesis 15 to +infinity. And there's my answer. Okay. Questions, comments, concerns? You have like 3 hours to do the homework.